Welcome to the DIY Honda Garage channel. DTC P0555 indicates a fault in the brake booster pressure sensor's A circuit, specifically identifying a high voltage condition. This diagnostic trouble code is crucial for ensuring the vehicle's brake system operates without failure. The brake booster pressure sensor is integral to the vehicle's braking system, as it informs the powertrain control module PCM regarding the brake booster pressure. The sensor is located near the brake booster assembly and connects to the PCM through a 3-pin connector. When the voltage from the sensor exceeds the expected threshold of 4.71 volts, this triggers the DTC. If the brake booster pressure sensor experiences high voltage readings, it can indicate short circuits, sensor malfunctions, or wiring issues within the MPMON line. Proper diagnosis is essential for maintaining vehicle safety. DTC P0555 pertains to the brake booster pressure sensor A, indicating a high voltage in its circuit. The brake booster pressure sensor plays a critical role in the overall braking system, as it detects the pressure level within the brake booster. Positioned directly connected to the brake booster, this sensor transmits voltage signals to the PCM, which uses that information to assess braking conditions. If the voltage reading is above the defined threshold of 4.71 volts, the DTC is activated. This high voltage can result from several issues, such as wiring shorts or sensor failures, which could potentially compromise brake functionality. Understanding these connections and their respective roles is pivotal for effective troubleshooting. The possible causes for DTC P0555 typically include short circuits in the wiring, a faulty brake booster pressure sensor, or an issue with the PCM itself. A short circuit can occur when the wires within the MPMON line create an unintended pathway to power, leading to elevated voltage levels. If the brake booster pressure sensor has internal malfunctions, it may transmit erroneous voltage readings, causing the DTC to activate. Furthermore, defects within the PCM may prevent it from accurately processing the signals received from the brake booster pressure sensor, compounding issues. Diagnosing these areas is critical for rectifying the high voltage condition and restoring optimal brake function. When DTC P0555 is present, several symptoms may manifest, impacting the driver's experience. One of the most noticeable symptoms is a warning light illuminated on the dashboard, indicating a brake system problem. Additionally, drivers may experience decreased brake performance, which poses a significant safety risk. An unusual feel in the brake pedal could signal potential issues, such as increased pedal travel or a spongy sensation, alerting the driver that the braking system may not respond as expected. Recognizing these symptoms is vital, as they indicate that troubleshooting and repairs should be prioritized to ensure vehicle safety and operational integrity. In the first troubleshooting step for DTC P0555, begin by turning the vehicle's ignition to the on position without starting the engine. This allows the vehicle systems to power up and the HDS, or Honda Diagnostic System, to read parameters accurately. Specifically, check the voltage output from the brake booster pressure sensor, which should ideally be more than 4.71 volts. If the reading exceeds this threshold, it indicates the current conditions are consistent with the DTC. If the voltage does not exceed this level, this could signify intermittent failures within the system and may warrant checking connections or terminals at both the brake booster pressure sensor and the PCM. For the second troubleshooting step, turn the vehicle's ignition to the off or lock mode. Following this, carefully disconnect the brake booster pressure sensor's 3P connector to eliminate any potential resistance that could affect the readings. Next, switch the ignition back to the on mode again and measure the voltage, between the designated test points on the disconnected connector. Test point 1 corresponds to the sensor's pin 1, and test point 2 relates to pin 2. If the measured voltage is 4.8 volts or higher, this indicates that the circuit leading to the sensor is functioning correctly. If not, troubleshooting should shift to assessing the wiring for defects. In this third step, the process begins similarly with the vehicle turned off. After that, jump the SCS line using the Honda diagnostic system to clear any stored faults temporarily. Disconnect the PCM's A connector, which consists of 51 pins, to facilitate accurate tests. Returning the ignition to the on position allows for measurement of voltage conditions across the specified test points. Here, you will check for voltage between the brake booster pressure sensor at pin 2 and the body ground. A reading of 0.5 volts or more points towards a short circuit in the MPM-ON wiring between the PCM and the sensor. If this reading isn't confirmed, you'll proceed to the next step for further diagnosis. The fourth troubleshooting step involves using a known good brake booster pressure sensor as a replacement. First, ensure the vehicle is switched to the off mode so you can safely work on the connections. After substituting the sensor, reconnect both the brake booster pressure sensor's 3P connector and the PCM connector A. With everything back in place, turn the ignition to on to energize the system. Utilizing the HDS, clear the DTCs that may be present. After clearing, cycle the ignition back to off and then on again to refresh the readings. Finally, check with the HDS for any reoccurrence of DTC P0555. If it appears again, further investigation into the PCM or wiring is warranted. In the fifth step of troubleshooting, start by switching a vehicle to the off mode. Using a jumper wire, connect terminals A and B, where terminal A is the brake booster pressure sensor's pin 2, and terminal B is the body ground. This connection will allow the HDS to read the sensor's ground reference effectively. Once connected, turn the ignition back to the on mode to check the brake booster pressure sensor voltage levels. If the voltage measures less than 0.1 volts, it indicates that the sensor is likely functioning correctly. If it exceeds this, continuity issues or incorrect grounding may need further investigation in subsequent steps. Moving on to step 6 in troubleshooting the DTC P0555. Begin again with the vehicle in the off mode. Remove the prior jumper wire and connect a new jumper wire between terminals A and B, which are now representative of the pins for the brake booster pressure sensor 3P connector at positions 1 and 2. This reconfiguration will allow you to effectively isolate the voltage readings from the sensor itself. With the connections re-established, switch the ignition to the on position and check the voltage output once more. A reading of less than 0.1 volts suggests a defective brake booster pressure sensor that would need replacement. If this condition doesn't match, you would proceed to the next step in your diagnosis. In troubleshooting step 7, initiate by switching the vehicle's ignition to the off mode for safety. Remove any jumpers from previous tests and disconnect the PCM connector A to isolate any faults. With the brake booster pressure sensor and PCM both disconnected, the next action is to check for continuity. Testing must occur between the brake booster pressure sensor's pin 1 and pin 20 of the PCM's connector A. If continuity exists, it indicates that the connection is intact and likely needs a known good PCM substitution if problems persist. In contrast, a lack of continuity suggests an open wire within the circuit that needs to be repaired to restore functionality. The final troubleshooting step requires starting with the vehicle in the off mode to ensure safety while working on the connections. After disconnecting various connectors, jump the SCS line using the HDS for diagnostic purposes. Again, focus on checking for continuity, specifically between the brake booster pressure sensors pin 2 and PCM connector A at pin 36. Continuity here is vital for the signal transmission from the sensor to the PCM's functional context. If the test indicates continuity, it's necessary to substitute a known good PCM and monitor if the readings normalize. However, no continuity means an open circuit within the MPMON line that needs repair, ensuring the system can accurately relay pressure sensor values to the PCM. Once all troubleshooting and repairs are completed, the final verification step involves ensuring that no DTCs remain in the system. This can be accomplished using the HDS to conduct a final scan of the vehicle's onboard systems. Confirming that the brake booster pressure sensor is functioning correctly is essential. The brake system should operate without unusual signs, such as warning lights or degraded performance. It's also important to reassess the brake pedal feel and responsiveness to ensure optimal function is restored. Conducting these checks not only confirms repairs, but also reinforces the vehicle's safety and operability for the driver. To maintain the functionality of the brake booster pressure sensor and prevent future DTC P0555 occurrences, implementing a regular preventive maintenance schedule is crucial. Start by routinely inspecting the wiring connecting the brake booster pressure sensor to the PCM for any signs of fraying or damage that may lead to short circuits. Proper cleaning of electrical connectors can help maintain appropriate contact and conductivity, reducing the likelihood of future issues. Additionally, periodic checks on the sensor's functionality with the HDS will ensure it operates within its designated parameters. This proactive maintenance not only increases component lifespan, but also enhances overall vehicle safety. In conclusion, DTC P0555 signals a brake booster pressure sensor issue that necessitates extensive troubleshooting to rectify. Each diagnostic step should be methodically executed to isolate the root cause accurately, whether it be wiring, the sensor itself, or the PCM. By following the troubleshooting guide, technicians can restore the sensor's functionality and clear the DTC effectively. Furthermore, implementing preventive maintenance ensures the longevity and reliability of the braking system, safeguarding against similar issues in the future. Understanding and adhering to these diagnostic procedures is essential for both vehicle longevity and driver safety. Please like and subscribe to the channel. See you next time.